You're soaked to the bone. Everything you're carrying is dripping water. Your lighter is dead. Your matches have dissolved into wet pulp. That fancy ferro rod? Useless now, just a cold piece of metal. Because your tinder washed downstream along with your confidence. The rain hasn't stopped for 2 days. The river has swollen beyond its banks. Your pack tried to swim without you, and now you're shivering so violently it feels like your teeth might fracture. Fire is the only thing standing between you and hypothermia, and right now, you can't make it. Not with soaked wood, not with modern gear that failed you spectacularly, but 2,500 years ago, Greek sailors lit fires during violent sea storms, waves crashing across their decks. They didn't have waterproof containers, they didn't have stormproof lighters, they had physics, they had chemistry, and they had a material so reactive it could ignite through sheer chemical defiance. They called it quicklime. We call it calcium oxide, and it doesn't care if it's wet. In fact, water makes it furious. And when quicklime gets angry, it gets hot. Hot enough to dry wood, hot enough to ignite tinder, hot enough to create fire using nothing but rock and water. Here's the science. Quicklime is created by heating limestone to roughly 900 degrees Celsius. This process drives out carbon dioxide, leaving behind a pale, caustic, unstable mineral. When water touches it, a violent, exothermic reaction occurs, generating temperatures between 150 and 300 degrees Celsius. That's hotter than boiling water, hot enough to burn flesh, hot enough to ignite dry plant material using pure chemical heat. The Greeks used quicklime everywhere: mortar, plaster, food preservation. But at some point, a sailor realized something extraordinary. This same reaction could save a life. Here's how they did it. First, take a lump of quicklime about the size of a walnut. Second, wrap it inside dry cloth or leather, something that contains it, but still allows water to seep through. A torn strip of shirt works perfectly. Third, prepare your tinder nest using the driest fibers you can find. Bark shavings, dry grass, plant fibers. Place the quicklime bundle in the center. Fourth, add water, only 3 or 4 drops. You are activating the reaction, not drowning it. Fifth, wait. Within seconds, the bundle begins to steam. It heats rapidly, too hot to touch. The chemical heat starts drying the surrounding tinder. Sixth, watch carefully. At first, you'll see white vapor. Then it darkens into gray smoke. The tinder begins to char from pure thermal energy. Seventh, blow gently. Controlled oxygen feeds the ember. The charred fibers ignite. You now have fire, created through chemistry instead of friction or sparks. But Greek sailors didn't stop there. They discovered that mixing quicklime with sulfur and charcoal produced something resembling an early thermite-like compound. It burned hotter, faster, and was nearly impossible to extinguish. Sailors stored this mixture inside sealed containers. When storms demanded fire, they simply added water and let chemistry do the work. They even created fire underwater. They wrapped the mixture in oil-treated cloth, sealed it inside clay vessels with a wick, and submerged it. Water slowly infiltrated the vessel, triggering the reaction. The wick ignited, allowing them to pull a burning torch directly from the sea. The Romans later weaponized this knowledge. They launched sealed jars of quicklime into enemy fortifications using catapults. The jars shattered. Moisture activated the lime. Instant infernos followed. Entire structures burned. If you wanted to produce quicklime yourself, ancient methods were surprisingly straightforward. First, gather limestone or seashells. Break them into fist-sized fragments. Second, dig a simple pit, roughly half a meter deep and wide. Third, line the bottom with flat stones to allow airflow. Fourth, place the limestone fragments inside. Fifth, pack dry hardwood around them. Mesquite or oak works best. Sixth, seal the top with mud, leaving a small vent at the center. Seventh, ignite the kiln and maintain temperatures above 800 degrees Celsius for several hours. The stones will glow with white heat. Eighth, allow everything to cool completely. The stones will now appear pale and brittle. That is quicklime. Ninth, store it immediately in a sealed, waterproof container. Quicklime degrades quickly when exposed to moisture in the air. Even today, it can still be purchased in hardware stores as calcium oxide, but it is extremely dangerous. It burns skin. It blinds if it enters the eyes. It damages lungs if inhaled. Ancient Greeks handled it with leather gloves and kept it away from their faces. Treat it like the chemical weapon it essentially is. This technology had a darker side. Armies used quicklime in mass graves to accelerate decomposition and limit disease. The same reaction that preserved food also erased bodies, life and death, controlled by a single mineral. And that reveals the real lesson. Ancient survivors didn't hoard equipment. They hoarded knowledge. They understood survival wasn't about perfect tools. It was about having options when those tools failed. They carried quicklime, flint and steel, bow drills, redundancy. They studied heat, combustion, and oxidation because their lives depended on it. Now imagine yourself again, soaked, freezing, but carrying a sealed container of this ancient knowledge in your pack. You unwrap a small piece, place it in tinder, and drip river water onto it. The same river that nearly killed you. Steam rises, then smoke, then a glowing ember. Within 5 minutes you have flame. You just created fire using the same chemistry that kept Greek sailors alive in raging storms. No batteries, no spark, no excuses. Modern gear will fail, batteries will die. But calcium oxide and water, that reaction has existed for millions of years. It existed before humans, and it will exist long after us. And right now, it could save your life.